Well, I take it you're kind of puzzled as to why I'm redoing week 14 online lecture. And well, part of that is because found out that I probably had some wires crossed with the headset. And so I'm re-recording. Now this could be good or it could be bad, but I suspect it's going to be good because it probably won't be the full 40 minutes that I had done before. I'm going to go through this a little more quickly than I did last time around. Now, this lecture is week 14. We're winding up bash. We'll have a chance in class to worry about project 6, and I've got the week 15 lecture coming, but what we need to get through today is about 20 to 30 minutes worth of this lecture, and then we'll move on to some talk on how to do math in bash using BC in particular. So without any further ado, we're going to dump the cheese and move on to more bash shell. Okay, let me bring up a new terminal. I want to get a terminal up here so that we can take a peek at what we're about to accomplish. Let's see here. We'll do that, get this going. You all get to hang around in the background while I'm putzing with logins here. Okay, so more bash shell, and let's just go forward here. So a cheap review of week 13. Shell scripts consists of commands, programming constructs, and comments. And commands like echo and read and awk and grep and if loops and case statements and that type of thing. But the other piece of that I really want to make sure that you do on a regular basis is comment. Comment, comment, comment. Comments are always appreciated. Comment to a fault. The other piece is you have to enable permissions in order for the script to run. So you have to have the execute permission set for the appropriate user. Well, in your case, yes, you want the user execute permission set, but then the group and the other as need be. One way, and the way I would tell you that works the best for me, and subsequently this is how I try to tell other people to do this, is you build a script as a series of blocks. You build a block of functionality, you make sure that functionality works, and then you start tying the blocks together into a complete package. As you're tying them together, you are retesting them to make sure that now this joined blocks of code work together. So you continue to test. Do a piece of functionality, test it. Do another piece of functionality, test it. Bring them together and test the combined set. So go from there. Next thing, input. You can read from the terminal using the read command. In its most basic form, you use standard in and assign it to a specified variable. So if I read answer, what I'm actually doing is I'm reading a variable called answer. If I do this and do read city, it will, okay, Topeka, right? Okay, echo $city. And it did what I asked it to do. In this case, it read my input for the variable city, and I told the shell that what I was decided to call the city is Topeka. So it can be invoked with 4 options: a -a, a -e, a -p, and a -r. Now the -a option will read a list of words in an array, and that is useful in project 6 because it's a read -a that will take the first name and the last name in, and that allows you to use those 2 names to find the appropriate entry in the name department password file. So that's your hint for week 6. The other thing that we talked about already is math is in the shell is integers only. You can't do floating point inside the bash, just using bash alone. You can declare -i, you can issue the variable let, or sort of, you can assign an integer value using let, but let, if you're going to assign anything with a floating point, don't use let. It won't work. And bash just doesn't do floating point. It just doesn't know how to deal with it. So you're going to use BC or awk to help you with handling floating point. So compiled commands can take in parameters from the command line. So can shell scripts. In other words, you can build a shell where the user will have to input a command or an argument. So, like the ls space -l, you can build your shell script so that you take in arguments from the command line. For example, if you wanted to grab a city name, you'd say what address space and then the name of the city. So anyhow, script is assigned parameter 0. So the name of the script is $0. Arguments, any arguments that are along with the script would be $1, and then anything greater than 9, in this case I said 11, has to use those curly braces, and that's a pain in the butt. So another, continuing, you can allow tasks to be performed on whether a condition is met using the if-else or else if then and else. You can use exit status to determine where things are going to be. Test command is available in bash. It can be test. You can use the word test or single square or double square brackets. And double square brackets are preferred, but it's more work. If you're using brackets, there has to be white space between the bracket and the expression. And you can see in this test that the white space between the bracket and 0 has to be there. That will work, but the 0 space, or the bracket 0 space -eq space 0 bracket won't work. So there's an awkward awk issue, and we touched on it a little bit, but trying to get a string with white space to resolve in awk is a bit problematic if the string is a shell variable. So let me do this. So I'm going to go ahead, we just set the city to be Topeka, but I'm going to assign it to Fort Washington. There it is. Okay. Now, echo $city, right? Because I had white space in there, I had to set the city with single quotes. But it comes back and tells me that's Fort Washington. Well, that's good. So let me see if I can find the DC area CSV. So let's cd to projects P6. And there is the DC area CSV. Okay. So let me do this. What am I asking this to do? Well, what I'd like it to do is print the first field anywhere inside that DC area.csv that field 12 equals what the value of city is, in this case Fort Washington. But watch what happens. Cannot open file Washington for reading. No such file or directory. So awk is telling me it has a problem with white space. Now I can try this. I can maybe put this regular expression format around it, right? Still doesn't like it. Unterminated regular expression, because it sees the fort and the space and is expecting the back or the slash to be there. So that doesn't work. Now what am I going to do? Well, we looked at this a little bit earlier. In this case, I'm going to set up a variable inside of awk. In this case, I'm going to set up a variable called city, and I'm going to set city equal to $city. and then we'll go in and look at this and see what happens. Sure enough, it finds it. Okay, so that works. So declaring that variable city using the -v within the awk command will handle the string with the space field. And of course here using this -f tells me that the field separator is a colon. Okay, so here's some of my thoughts on Project 6. As always, there is no one right way to accomplish the goals. Now, I built a solution that used a case statement, nested loops, awks, BC, and tests, as well as I read input from the command line. I used a couple of temporary files to store information. I used exit codes to get things in and out. Basically, I built it up, and we've talked about it in class. There is about 7 different functionalities that you need to make work in Project 6. Once you get each individual one of those put together, you should be able to combine the whole set and make it work. So when we get to week 14 in class, we'll deal with some files in here, and I might as well get to that area myself. So let's go back to square one and week 14. Okay. So testing of files is used in production system scripts. Often an arrival of a file can be used to trigger processing, and I'm going to sidetrack a bit and talk about batch processing and cron in Unix and Linux. So there is in the Unix shells by example on table 14.5 some examples of testing operators that use the -f, the -r, and the -s. There is a file called perm check underbar. Let's see what we've got here. We've got perm check underbar R1. So let's cat this. Cat. And I'm just going to grab this, copy it, and paste it down here. So this is a file test using old style test commands. So if I'm going to do the -d, if it's a directory, the file is a directory, it will echo the file as a directory. Else if the file exists and it's writable and it's readable, writable, and executable, echo you have read, write, and execute permissions, else you have partial permissions. Echo file is neither a file or a directory if it doesn't exist. Okay. So I'm going to, there are 3 file test files in here, and you can see, well, there's actually more than that, 1, 2, 4, and 5, and we'll do this in class. The cron tab is a device that allows you to schedule the execution of scripts, shells, or jobs. Jobs or shells are executables that have to run at specific times. Scripts are often built around testing conditions for scheduled events, and the pieces are put in place to run a specific executable, for example. So there's a nice Wikipedia page on crons that you should be able to take a look at some point. The null command is represented by a colon, is a placeholder within an if command. It returns an exit status of 0. It basically allows for a clean exit from a then when no processing is required. And without the null command, it would exit with an error. So inserted within a loop, it will make the loop infinite. So you have to be careful with them. So here's a device called wholenum.script and wholenum.shell. So I'm going to enter an integer. If the expression number plus 0 is greater, send that to the dev null, then else you did not enter an integer value. So if I do wholenum.shell, right? Wholenum.shell, 22.5, you did not enter an integer value. Okay, wholenum.shell 1. Notice what the colon did. It just exited the shell. Echo dollar question mark. What exit code did I get? 0. Let's do this again. 22.5, right? Echo dollar question mark. What should I get? I should get an exit 13. And sure enough, that's exactly what I got. So, we'll run this in class 2. There's a case command, and you can use the case in Project 6. It's pretty good. It does some nice things. It allows you to filter through a number of iterations of choices a user can make. The choice that will be made most often very much should be the first item in the case string. So it's case, what value, ESAC. In other words, you start it with case, check for something in, and then look at the value, evaluate it, do some action. The 2 semicolons have to be there in order to drop it through to the next evaluation. So there's this number underbar R1 dot shell. We'll take a quick look at this. So this is look for a specific number. Wrong, thanks for playing. Wrong, thanks for playing. Wrong, thanks for playing. 3, we have a winner. So if I do a number underbar R1 dot shell, if I give it a 3, it's filtered all the way through to find that. Okay, let's do this again. 4. Yep. 4. Wrong, thanks for playing though. Notice it just quit. Okay, it found a response. Let me try to break this with a 110. Didn't even come back. It's not cared for at all in this. So how do I fix that? How do I grab something that isn't there? Number underbar R1 dot shell. So I'm going to go down here. I'm going to open that. Stick a tab in here. Stick a splat. Paren. Echo. Unexpected. Yep. There we go. Let's write this to number underbar R1R dot shell. And quit out of this. And let's do this number underbar R1R dot shell, right? Okay, permission denied. So Shamad 755 number under number underbar R1R dot shell. Now let's try this again. So 110. I'm sorry, Dave, I can't do that. So what did I end up doing? The splat took care of any other response that doesn't make any sense to the case statement. Let's try that again. Let me give it a character, F. Again, I'm sorry, Dave, I can't do that. It doesn't match any of its previous examples, but because it's the wildcard splat, it will match everything. So there you go. So moving forward, loop commands. You do until you've reached the end of the list. For example, the for loop suggests processing a finite number of items. The while loop can process indefinitely. The until loop continues until a break condition is fulfilled. And you can use a command called select to create menus, which is interesting, and that is helpful with restricted shells. So there's a looping command that we'll take a look at in class. It's greet.shell. Now let me do this. I know it says less, but let's take a look at greet.shell. So basically, I'm going to use $@ to get single quoted names into the script cleanly. I'm going to echo hi $name for name and $splat. So let me do this. Come back here. So let's do this. Hi, Hugo. Hi, Becker. So what now? If we change that a little bit, we may make things work a bit differently, but I'm not going to go it. So if we do this, including the oleanders, for instance, you'll get the ole and the anders, right? However, let's try this, oleanders. Hi, oleanders. Because you put it in single quotes, he automatically said, don't worry about the white space. That's not another argument. Okay, so the while loop continues with an exit status of 0. It breaks out of the loop when the exit status is not 0. Basically, until the condition is met, an action that will continue to occur. So it can be infinite. And then there's a number of shells here that we'll play with in class. Okay, so let's look at these. Until loop continues with an exit status of non-zero, it breaks out of the loop when the exit status is clean. So it's the opposite of a while. Sets up with until do done. So you can take a look at this number under bar R3.shell. We'll do that in class. And then select loops can be used for creating menus. So there's this runit.shell. Let me run this. Runit.shell, right? So what does it do? Well, I've got 3 things I can do. I can do 1, which gives me this. I can do 2, which gives me a path. And I can do 3, which is a date. But what can't I do? There's no exit in that. So Control-C to break out of it. Okay, so let me try this runit under bar R1.shell. This time I have an exit. Okay, and that's actually the command, exit. So looping commands, there's a select loop here, select, do, case, csac, done, and this ttype.shell. And this actually was used quite a bit when I was growing up, because your terminals would be different and they'd have to be set. And so WISE 50, VT200, Xterm, or Sun. And if you didn't have the right terminal, all kinds of nasty things would happen. So there's break, continue, and nested loops, and we've talked about these before. The break command is used to force an immediate exit from the loop. The continue returns control to the top of the loop. You're going down, you're counting 1, 2, 3, 4, 5. Hey, when you see 5, don't do anything else, just iterate the number and go back to the top. Now, what can happen with the continue loop? If you don't iterate the number, it will see 5 again and keep going back to the top and doing nothing. It'll keep banging back up to the top of the loop. So that's important. That's something to keep in mind. It can be infinite. So there are nested loops that allow you to do more sophisticated processing, and we'll look at a couple of these in class. And there's also a break loop that we'll look at in class. There are all sorts of things that are going on in this little shell, and we'll take a look at them. Again, the notion is it's not right or wrong, but does it work? You can do, there are several looping control commands that we won't get into. The shift command shifts parameter list to the left. In other words, it moves itself forward through a set of parameters. You can use it within a while loop. For instance, I did use attempt and first, second, and third in a while loop with project 6. The other thing is you can exit from a loop using conduction with a while loop, and there's something out here called loop break. And there's a continue command. Again, we've seen that in the past. So anyhow, we will get into more of this in depth in class. And I think I've just saved you a bunch of time. So for what it's worth, that's the end of the week 14 lesson, but stay tuned for parts 1 through 3 of doing math in Bash. See you in class.